Hey guys, welcome back to Predicta restoration tips for the 17-inch models. In this video I'm going to be talking about how to make those final adjustments to get the best possible picture. I'm talking about screen geometry, brightness, contrast adjustments, and so on. Now I just happen to have a set that I recently restored, got up and running, and I'm at that point where I need to make those adjustments. Now as you see it, the plastic enclosure is off the CRT head. You do not need to do that to make these adjustments. I happen to do it so I can clean it and tighten down some loose bolts, but I'm going to leave it like this so you can really see what I'm talking about and the adjustments I'm making. Now I'm starting with the assumption your set has been overhauled and is otherwise fully functional. We're going to start out by making adjustments on the back of the set. There are a whole bunch of them back here. Some you might not even be aware of. The obvious ones are the three in the upper left here. Starting on the far end we have brightness, controls how bright the image is. In the middle we have vertical hold, that will stop the picture from rolling vertically if you need to, and horizontal hold, which will lock the picture horizontally. They put those up on top so you can reach them from the front and adjust them easily, because those are the ones you most often need to adjust. Ideally, if you have a strong signal coming in and you've done a good job overhauling your set and you have fresh tubes, the horizontal and vertical lock should be pretty stable. Brightness, unfortunately, you may very well want to tweak depending on the type of programming you're watching. I'll talk more about why later. Going on the other side of the chassis, we have 4 adjustments you can make with a flat-bladed screwdriver. This is the width control, controls how wide the image is. Next to that, vertical linearity. This is not the original. Often the originals are bad, but they look somewhat similar to this. Whether it's the original or in this case this replacement, you still need a flat-bladed screwdriver that controls how the image looks progressing from the bottom to the top. So if something is egg-shaped, in other words it's squished at the bottom, stretched at the top, or vice versa, that's your control you want to adjust. Height is directly below that. That controls how tall the image is, or short. And next to that we have the horizontal frequency control. And the final one back here, you're going to need a special plastic hexagonal tool. You insert it from the top. This goes by a few different names. Flywheel coil, resonant coil, or ringing coil. It helps the horizontal oscillator stay on frequency of 15.75 kilohertz. Back of the CRT we have 3 magnets we can play with. There are 2 versions of yoke that they used. On this version we have concentric rings with tabs that stick out that we can rotate, and they control how the picture is centered. And then this weird looking thing, it's a piece of magnetic material that has a hexagonal hole down the middle. You can put an Allen wrench in there and carefully rotate it. This is fragile material and it's held pretty tightly in this metal sleeve. It's very easy to chip it. It's basically a crude way to adjust the horizontal linearity. All 3 of these magnets work by affecting the yoke directly behind them by either giving a little bit of a magnetic assist or restricting the magnetic field generated by the yoke. Alright, so where do you start? What adjustments do you make? Well, the first thing we need to do is hook up a test pattern generator. Yeah, you can kind of eyeball this with just some over the air or play a DVD programming kind of thing and look for, well, back in the good old days you could stay up late and watch for a test pattern. But otherwise you could watch people's faces and kind of, you have some idea of what a person's face should look like, or if there's a clock on a wall, you can adjust it so it's round. You can certainly make adjustments so the image fills the screen. But to really do this right, you need a test pattern generator. For the past few years, I've been using a Sencor Universal Video Generator model VG91. It's not for everyone. It's a fairly large piece of equipment. Might have a lot of features you don't need. In other words, it would be overkill. However, NTSC equipment is all obsolete now. You can get broadcast quality gear really cheap. So, hop onto eBay, search for NTSC test pattern generator, and you'll find all kinds of stuff. There are small modern ones that can do PAL and NTSC and ATSC and all kinds of stuff. Just be aware that the user's manual will probably be very lacking if you get one at all. I like stuff that's kind of from the 80s and 90s. Usually it just works. It's solid state, you plug it in and turn it on. I like to have reliable test equipment. Yes, you can certainly get test pattern generators, flying spot scanners, a B&K 1077, but you're going to have to restore your test pattern generator and make sure it's working properly before you can adjust your TV. So I like to get something that's relatively modern that I can just turn on and use. Rather than go through all the functionality of this, if you get this model, you want this control to be fully counterclockwise, standard TV. RF range, generally the mid-range, and the level mid to high for the adjustable below it. Take your RF output through some coax and clip it to the antenna terminals on your TV. Ideally, you can set your pattern generator to the same channel that you're going to be using when you're watching programming on your TV, and you'll have a similar signal level that you're feeding into your TV. In this case, I'm going to use channel 3, and we have a number of test patterns we can choose from. For the adjustments, we are going to make the window circle and the crosshatch are the main ones we're going to be using. The circle, we'll put a circle on the screen, which helps us make sure it's circular, not egg-shaped or lopsided. And the crosshatch, we'll put squares across the entire visible area so we can make sure we have uniform size squares over the entire screen. Reduce the lighting a little bit so hopefully you can see both what's on the screen and see what I'm doing. First thing we're going to do is power up the set and let it sit for about 15 minutes to make sure it's fully warmed up. You may notice when you first turn on the set, the picture isn't locked, but ideally, after a short while it is. Now the first thing I want to do is make sure that I've got the set tuned to the channel I'm working with, in this case channel 3, and that I've got a good, strong image. That's not so good. Maybe I do need to increase my signal level. Let's go to high. Yeah, okay. But there's also, well, not on this model. Alright, so, this is a debutante with an 11L43 chassis. It does not have a local distance switch. Every other model Predicta does. Without that switch, it means the gain of the set is locked to a predetermined level, and they made these for closed circuit systems, so I think these sets have less gain than the other models. Normally, I would put the set on the distance mode, which means it has more gain, in which case I can use a lower input signal. You may want to play around with that switch and adjust the level of your generator to get a good image. What do I mean by good image? Well, if I lower this, that's not so good. If you get it low enough, the set can't lock very well. That's what I meant earlier by if you put a good strong signal in, your set should just lock when you turn it on without you have to ever touch the horizontal and vertical hold. I don't have a strong enough signal, so it just can't lock. Alright, now it's locked, but there's a lot of snow. Ideally we want a black background and then sharp white lines for our test pattern. Now I also have the brightness on this set turned up way too high, so let's knock that down. Alright, that's pretty good. Of course, there's also fine tuning on the front of the set, so you want to make sure that that is adjusted properly. Now I'm off channel and it's getting a little funky. You might want to use a different test pattern while you're doing this so you have more stuff to look at. Let's go with the bars. Better yet, let's use this one. This is a multi-burst pattern. It's tuned in pretty well there. Brightness back down, and let's get back to our circle. Alright. The height and the width are pretty good, but notice we have a gap over here and we don't so much over there. The image is shifted to the right, in other words. Now this set also has a particular situation where the picture tube has been replaced, which means it might not be possible to get as perfect screen geometry as it had coming out of the factory, because the CRT might be a little different from what was in there originally. It might not be the same picture tube type, in other words, but you do the best you can. So let's see what effect the width control has for starters. So here we're making it narrower. How do we know when it's too narrow? This line should extend all the way to the edge. And keep in mind, these sets do not have any voltage regulation. So I can put this so that edge of that tip of that line is right at the edge of the screen. Perfect. Give this back to the owner, he takes it home, plugs it in, and it's over by ½ inch. Why? Because the line voltage out of his wall might be 5 volts lower than mine. So typically when you adjust these, you overscan it a little bit. Put it about 1/4 inch off the edge of every side. Also notice when I change the width, now it's too tall. We have an egg, we don't have a circle anymore. So we want to shrink our height. And yeah, we need to get the right edge too. To do that, we're going to need to use those centering rings on the back. I just want to get you some idea first of what all these controls do. So this is the height again, your small flat-bladed screwdriver, and here we decrease the height. How do we know we don't have enough height? Well, we've got a big gap here at the bottom, but the top is filled in. Well, what the heck do we do about that? Two things. One, adjust the vertical centering, but this looks like it's centered pretty well. You kind of eyeball it with the adjustment, or sorry, the mounting strap here. The middle of the screen is right about where the line is right now. That's where the vertical linearity control comes in. Adjust that. Well, that's making it a whole lot worse. And hey, now we have screen roll. Yes, this is the fun of adjusting TVs, in particular the vertical. The vertical hold, the vertical height, the vertical linearity all interact with each other. Let's try adjusting this the other way. Linearity is looking pretty good, but it's not tall enough. So now we go and we adjust our height to make it taller. That's pretty good. But what we really need to do is the center of the screen, because it's a little bit too high and it's a little bit too far that way. So to do that, we need to go to the magnets on the back. Well, wait a minute. Well, I can't see the screen. Yeah, that's that's one of the pains. Now, Predicta is a special treat to do this on, because you can swivel it around. You can't do this on a normal TV, big console. What you typically do is get a mirror, like a floor standing mirror, and mount it 6 feet away or stand it up or something so you can see the front of the screen while you're poking around in the back. Because you really don't want to be looking at the front and reach around the back and fiddle around and fumble for stuff. because you could shock yourself. Now with this cover off, I have a high voltage terminal here. There's about 15,000 volts right there. I don't want to get anywhere near that. Some of these pins have around 400 or 500 volts on them. I don't want to touch that either. The yoke has some pretty nasty pulses on it. I don't want to get near that either. However, luckily, where these centering tabs are, there's nothing. This collar that tightens down, that's grounded. This is grounded. None of this stuff is going to shock me. Just don't go wandering around. Now normally, again, the plastic cover would be on here and it would have an opening, so what you could get at really is those rings, so that'll give you a lot of protection. Let's get in here a little bit closer so you can see what I'm talking about. Here is one tab, here is the other. There is some science to how these work, but I suggest you just play around with them and get a feel for how they work. Generally, when you move the two together, it will move the screen in one direction, and you move them apart, it will do it in another. But then, of course, you're going to rotate both of them all around. And I don't know which is the north and which is the south pole or any of that, so you just try it. So I'm going to let you see the front of the screen while I get around to the back. So let's see. I'm just going to move one of the tabs. Okay, that moves it down, but not perfectly down, because these are traveling in a circular manner around the neck, so you're not going to get linear action unless you move both of them at the same time. You're going to get it's kind of go down and to the left and then back over to the right. But we do want to get it down, so that's good. But now we've also moved it way too far over to the left. So let's try moving the other one. Try going this way. Oh, okay, now we're getting it going back the other way. And that's actually kind of looking alright. But notice we have a little bit more missing on this corner than we do over here, even though this distance is pretty darn close to that distance. And that corner is also clipped, but this one is not. I think our vertical linearity is off a little bit too. We also need to bring the image down a little bit, so let's keep at it a little. Let's see. It's going down, but now it's going back to the left. I'm going to get it to go to the right. I need to go up a little bit, and over to the right a little bit. This is tedious. This is not fun, but the rewards are you get a really good looking picture. The corners all look really good, but we have a bit of a gap down here at the bottom. If I increase the height, it's already not quite so circular anymore. So I'm going to increase the width a little bit. You're going to have to make compromises when you do this. In fact, somebody posted recently in a forum where they took a picture tube and they measured the dimensions, and it was not an aspect ratio 4:3, which is what the broadcast is. It was off a little bit, so it would be physically impossible to get the picture to fit perfectly on the screen because the screen is not cooperating. Alright, we definitely need some more height, so let's go up with that a bit. Now, there are other test patterns. Ideally, I would be having the Indian test pattern, because that has more details. In particular, it has a target in each corner. I'm just working with a rectangle with a circle inside of it. So I don't know exactly the extent of the visible area, but I've used this generator a lot. I know pretty much if you get the tips of these lines in the visible area, you're all right. Ah, boy, it's still, it's a little irritating because it looks like the bottom half of this circle is already a little bit longer than the top, but the tip of this is not all the way down, but the corners are being clipped off. So, what's a person to do? Well, we're going to try to shift the whole image down a little bit more. Well, it does not. There we go. Alright, so now I'm just where the top is just kind of coming off screen, so it's kind of... And we need a little bit more height. We just barely have the tips of both of these in the visible area. But the circle is already being stretched beyond circular. That is the main thing you're going to notice with this when things are off, is if the vertical linearity is off, especially if it's really egg-shaped, because everybody's head, things that you're really familiar with, again, a clock on the wall, the wheels on a car, if those are wrong, that really is a glaring defect. If the corners get clipped, I mean, after all, this isn't a square picture tube or rectangular anyways, it already has rounded corners. The corners are going to be clipped off no matter what you do. Alright, that is looking pretty darn good. Let me back up the camera a little bit for you. Alright, what do you think? No, it's not perfect. This is something I've had a trouble with from the day I got this set and first got an image on it, is that this side is kind of weird, curved. This line is not straight up and down. This line is straight up and down. On this side it looks pretty straight up and down. That is not. Sometimes you just have to live with it. That, again, gets to do with the yoke and the magnetic fields and how well do they make the glass envelope on the picture tube. I've heard that back in the day, servicemen would have some little sticky magnets in their parts caddy, and they would place them, say, inside the plastic shell or on the back of the glass picture tube to try to correct for these defects. That's way beyond. I don't know if that's true. For one, I think you'd lose your mind trying to do that. Basically, we're trying to do pincushion correction with a set that doesn't have it. Well, later color sets, when they got a solid state, there were more adjustments you could make, like trapezoidal adjustments and such. Back in the day when this was made, you don't have any of that stuff. What we do have, though, is the one we haven't touched yet. This way. We have this guy. But let's go with the grid pattern before we start messing with any more stuff. I'll also say this too, if you get it looking pretty good on this, when you're watching broadcast material and stuff's moving around and all that, it'll look fine. Now we can get a much better idea of where we're at as far as the overall condition. Get rid of that white too. Let me turn the brightness down a little bit. Having too much brightness can kind of stretch things too. Oh yeah, here's another weird effect. Notice when I turn the brightness up, the shape of the squares changes a little bit. That is another side effect of no voltage regulation. When you turn up the brightness, you're increasing the current to the electron gun. That actually drags down the high voltage, which means it's easier to deflect. So the varying brightness of the image can distort the image. It changes the screen geometry a little bit. It's a little maddening. Look at this bottom line as I change the brightness. It moves up and down. Now, normally you would never watch the set with the brightness all the way up, so let's kind of get it at where you might normally have it, which would be about there. That's pretty darn good, believe it or not. The squares are a little bit closer together on this side than on the other side. A lot of things can affect that. The damper tube, the horizontal output tube, the horizontal drive signal, the yoke, and then finally that horizontal linearity adjustment. Just so you can see what it does, I will grab an Allen wrench and tweak it a little bit. I don't really think this warrants an adjustment, but I want you to know what it does. If I'm reading my Allen tool set here correctly, I am using a 7/32 Allen wrench. Just fits right in there. Now notice there's only one on one side, which means when we adjust it, we're only going to be affecting one side of the screen, which happens to be, when you're viewing it, the right side of the screen. Why does that matter? Well, the way these sets work is the right side of the screen is really being driven by the horizontal output tube. The left side of the screen is the damper tube. Now, unfortunately, the right side of our screen is the one that's pretty good, and the left side is not as good. That's why I was saying I wouldn't really make this adjustment. I'd be more inclined to change the damper tube. But anyways, here we go. I'm going to tweak it a little bit. So yeah, it's squeezing in the right side. And what we can try doing, though, is we can squeeze in the right side, and the left side's also a bit squeezed in. Now we can adjust the width to stretch it out. However, in the middle, the squares are pretty square-shaped. But let's increase the width a little bit. I think overall that is slightly better. Slightly better. If I was to tweak it the other way, now it's stretching the right-hand side. Let's go back a little bit. After all, the action's in the middle of the screen. That's where you're looking most of the time. Focus on getting the 75% or so in the middle of the screen as perfect as you can. Now it looks like to me it's stretched a little bit vertically in the middle and then compressed a little bit at the top and the bottom. The linearity isn't and that's a common situation I've seen. I think it has to do with the curvature of the screen and whatnot, that you can try swapping the vertical output tube, you can fight with the linearity control, you can fight with the height control. I notice we're not quite reaching all the way to the bottom anymore, so I think I do need to tweak the height a little bit. So that is the basic idea of getting the screen geometry right. You're going to pull your hair, you're going to swear, or maybe you'll get lucky and it won't be too bad to begin with. But I generally find this to be tedious and frustrating, and sometimes you just can't get it very good, especially on early rectangular sets. But that's about as good as I've ever seen on one of these sets. Something else you should do is tune your channel to something that doesn't have a signal on it, and then go back, and it should lock like that. That's excellent. Alright, what about brightness and its related control? Contrast. This set does not have DC restoration. What does that mean? Well, if you look at the standards for an NTSC broadcast signal, they specify voltage levels for black and for white, and specifically their relation to the sync pulses. Let's say, for sake of argument, because I don't remember what the values are, that a sync pulse, which is negative in America, and NTSC, is negative 1 volt. And then black is 0 volts, and white, the brightest white, is 1 volt. Well, typically on TVs, especially lower cost consumer TVs, at some point they AC couple the signal, typically to the video amp or to the picture tube, which means you lose your DC reference point. Well, what does that mean? It means, let's say you have an image that's pure gray, it's half a volt, you feed it through a capacitor, it's going to drift. It might drift down towards black, it might drift up towards white, but it's not going to stay at 0.5 volt. More expensive sets, more complicated sets, use DC coupling all the way through, and it will stay at that 0.5 volt level. And you're thinking, well, you're receiving a signal of varying levels, and it's being amplified and such. How does it know about that 1 volt range and 0.5 volt and all that? Because you use the sync pulse, the tip of the negative going sync pulse, as a reference. Everything is relative to that. So that's how DC restoration circuits work, is they have a clamp in there, and they detect the negative most point in the signal that's being received, and they use that as a lock, and everything is relative to that, and they use that to reinsert the DC offset level. Could you modify this set to have that? Sure. I haven't seen, well, no, I shouldn't say that. I do believe somebody tried doing it on the Antique Radio Forum, and he had trouble. Because when you start adding in a clamp and then a capacitor and feeding it a DC offset and whatnot, you disrupt the signal flow. And he was having trouble, I think, with shading issues, where he was adding gradations, or it can degrade the bandwidth a little bit. So it's not as trivial to do as it might sound. Alright, so what's the impact in the real world? If you're watching a movie and it's a couple people sitting in a room with the constant lighting level for the whole movie, you can adjust the set and just watch your whole movie, never have to have any concern about it. If it goes between nighttime and daytime and inside and outside, that's when you get issues. It may be a very dark scene, and you increase the brightness a little bit. Typically, what does the brightness control do? It adds a DC offset to the AC coupled video signal. So you boost the dark scene a little bit so you can see it, and then suddenly they go to a bright noonday outside scene, and now everything's washed out, and you have to reach over and turn the brightness down. That's annoying. Notice on these test patterns when I go through them, looks great, looks great. I can only see 1/3 of the screen. What the heck? I can't see the left side of it. It's just obliterated. I have to turn the brightness up. Hey, there's all my bars. Go back to the others. No, it's way too bright. It's washed out. That's the problem. What do? You compromise. You play with the controls. You're going to have to get off the sofa now and then, especially annoying when they go between commercials and then a nice black and white movie you're watching, and then you jump to bright modern color TV commercials, and it's a little jarring, but that's the deal with that. Brightness, so you adjust brightness so that, well, everything, you can see everything. Black is as black as you can get it, while still maintaining bright in other areas. Oh, and if you're noticing some distortion here and there, it's because I turned my signal level down and I just have some alligator clips feeding my signal in. Ideally, you would have nice coax connections that tighten down going from signal source into your TV. Minimize that. Alright, contrast. What does contrast do? Contrast controls the gain in conjunction with the local distance switch if you have it. Right now I have minimal contrast. That amplifies the video signal, so it increases, makes the brighter areas brighter, the darker areas darker. If I put it up all the way, generally if you get the contrast up too high, it gets too harsh. I can kind of simulate that by turning my signal level up all the way. And you might have trouble with the sync pulse, actually, because I'm overdriving it. I have too much gain and some of the circuits are being overwhelmed. If I turn the contrast back down, hey, now my sync is good. Too much contrast. Alright. Can't see the left side of the screen though, so we need more brightness. Now it's a little bit overpowering again, so we're turning the contrast down. And now it's kind of washed out. Well, that's because I have too strong a signal going into the set, so let's turn that down. Now we're getting some distortion. I'm going to turn that back up. I'm going to turn the brightness down. So I think you get the idea. I hope you get the idea. Depending on the strength of your signal source, how you have your local distance switch set, You have your contrast control set. You play around with the brightness. Depending on what you're watching, you're going to have to play around with those. There is no magic. Set it to 1/3 of the rotation and it's always going to be great. No. That's why they make the contrast easily accessible from the front. Brightness you will adjust less, I think. That's what I put it, so it's a little less accessible, but contrast is right up front. It's right around the volume control. Now, I don't want to get in trouble from the copyright police, so I'll keep this brief. I'm using an over-the-air converter box, goes from ATSC to NTSC, taking the output on channel 3 and going into the tuner. I don't have the best connection, so there might be a little bit of interference, but overall it should be pretty good. Now notice it's taking a while to lock in. I need to do a little bit of work on that ringing coil. But hey, there we go. And now I would want to adjust my contrast. I think it was a little bit too much. Tweak my brightness a little. I think we did pretty good. It is filling up the entire screen nicely. The linearity looks pretty good. Alright, that is the gist of it. I'm going to now bring up the service info and let's talk more about that ringing coil. There's a procedure for how to adjust that coil in both the Sam's Photo Fact we're looking at here and a slightly different procedure in the Philco factory service info. Let's go with the Sam's. I think it's a little more straightforward. Turn the set on. Tune in a station signal. Well, we don't have any broadcast stations left, but use your RF modulator, test pattern generator, what have you. Allow the receiver to warm up. Connect the clip lead across the horizontal stabilizing coil, aka the ringing coil, the flywheel coil, the ring, what have you. Set the horizontal frequency control until the picture appears to float back and forth across the screen. It's a little vague, but okay. Remove the clip lead and then adjust the horizontal frequency slug until the picture synchronizes horizontally. Now they call it a horizontal frequency slug, but I think they mean the slug inside of the horizontal stabilizing coil. Alright, it sounds simple enough, but how do we get at that coil? Well, here it is on the schematic. Here they call it a ring coil. Go figure, just to keep confusing people. Well, actually, no, this is the Philco service info, so it makes sense that they have a different name. So Philco calls it the ringing coil. Sam's calls it the stabilizing coil. Alright. Here's the issue. One side of it goes to the plus 260 volt main bus. So there's definitely a shock potential there. And the other side of it goes off to horizontal oscillator test point. Well, that might be handy. That, I believe, is an unused stake near the edge of the circuit board. We might be able to get at that. And then we could just short that to any point on the 260 volt bus. In other words, we could short these two lugs together. Maybe there is a method to this madness. Let me see if I can identify those on the back of the set. Yeah, actually it's not as horrible as I thought. So there is a stake right here next to the coil. No wire attached to it. That's that test point. This is a 260 volt bus. You just need to short that to that. So I'm going to get an insulated alligator clip and give it a try. Now, when they say to turn the set on and warm up and then to short it out, I'm going to short it out before I turn the set on because I don't want to be playing around with 260 volts given that all the metal around here is ground. Alright, I have that coil shorted out. Nothing's floating, so let's try adjusting that horizontal frequency control so I can get it to lose sync. I don't know about floating. That's why I said I don't know exactly what they mean by that. Alright, well I've got the control at one extreme and nothing's happened, so let's go the other way. I'll go till we just lose sync. If you go way off frequency, bad things start happening because the circuit's just way too out of whack. I'll do it. Trying to get right at the edge of where things go haywire. Let's say about there. Alright, let's pull the jumpers off. Alright, and then you're supposed to adjust the slug so the picture's locked. And there we go. Alright, I'm going to try adjusting the horizontal hold. Alright, that does its thing. Now let's turn off channel and back on. Locked. Alright, now the big test, turn the set off. Going to let it cool down, turn it back on, see what happens. Alright, now what about the controls on the front of the set? Well, I'm just going to run through them briefly. The inner knob here you push on, push off, rotate for volume. What that means is you can leave the volume at a pleasant listening level, turn the set off, turn it back on, the volume will be just where you left it. Outer contrast, that's what I was playing around with. Adjust it depending on the programming you're watching so it looks the best to you. And all that's left is the tuner. Rotate this for your channel. These days we're probably going to just be leaving it on channels 3 or 4 and never touching it again. And then the outer is fine tuning. Now there are adjustments you can make on the tuner itself. Some of them you can get at by pulling this knob off and getting in there with a special long tool. That gets a little complicated. Ideally you'll never have to do it, but I want to talk about that in a separate video because another issue with the tuner is you may need to clean it. And there are some tips and tricks on doing that. So that is it for the controls on the front. Alright, let's see how we did. Now, I'm trying to set your expectations to something realistic. No, a vintage TV will not just turn on and always have a perfect picture without any need for adjustment like a modern flat screen TV. However, don't accept that, oh, it's an old TV, the image is never going to be that great, it's always going to need some adjustment. No, if you go through, restore the whole set, replace all the out-of-spec parts, put in good tubes, make all the adjustments, it should lock in within a few seconds or so without you having to tweak it. Alright, there we go.
Why not? Listen, Saturdays at 6, 5 Central on BTV.
And the picture looked great when I turned the set off, but now it's a little harsh, modern programming, so now I'd want to turn the contrast down, maybe turn the brightness up a little bit. That you're just going to have to deal with. But otherwise, I hope these tips made sense. I hope they're helpful to you. It can be a little frustrating at times, but stick with it and you will be able to get a really nice looking picture on your set. Thanks for watching.